Hello, this is Geometry 10.3. In 10.3, we'll be using chords in a circle. So recall that a chord is a segment in a circle whose endpoints are on the circle. So this would be chord AB, and it's a segment, sorry, right? Segment AB. Again, this means chord AB, but notice that chord, its endpoints are on the circle. So there's an arc in the circle with the same endpoints. So there's arc AB, and then here's how I would write it with a little arc symbol above it. This arc right here is the arc of the chord AB, since they both have the same endpoints, or this chord is the chord of the arc AB. All right, and then talking about theorem 10.6, the congruent corresponding chords theorem. So if we're taking a look at a circle like this one up here, and I have two congruent minor arcs. So let me draw another minor arc in here. Call it arc CD. If arc CD is congruent to arc AB, then their corresponding chords are congruent, or vice versa. So these two chords, the chords of the arcs CD and AB, would be congruent with each other. Again, or vice versa. So we can write it as a biconditional statement. And this is the corresponding congruent chords theorem. So I have two minor arcs in the same circle, or it could be congruent circles. They're congruent if and only if their corresponding chords are congruent. So the arcs are congruent if the chords are congruent, or the chords are congruent if the arcs are congruent. And keep in mind that you would measure a chord. A chord is a segment in terms of just whatever your units are. Could be centimeters, inches, feet, or just basic units. You measure the arcs in terms of degrees, because remember the measure of an arc is equal to the measure of its corresponding central angle. So you measure an arc in terms of degrees. And then theorem 10.7, the perpendicular chord bisector theorem, states in a circle, if a diameter, so I'm going to call this diameter AB. Remember, the diameter is a chord that goes through the center of the circle. But if a diameter is perpendicular to a chord, let's call this chord PQ. If it's perpendicular, then it not only bisects the chord, so whatever the point of intersection is here, I'll call it point T, then PT is congruent to TQ because the diameter bisects the chord. If it's perpendicular to it, it would also bisect the arc of the chord. So arc PB would be congruent to arc BQ.